Okay, and then we shall start the webinar right now. And what we are going to talk about today is the MQTT protocol that is quite the standard of the industry for the Industry 4.0 and the IoT. And our HMI plays an important role for this part because we have supported so many PLC devices, and we can talk to so many machines. So we are able to wire the message from your machine to your MQTT servers or to your message services. So what we're going to talk about is MQTT, and what I'm going to cover in this webinar first is the what is MQTT and how our HMI fits in the MQTT system. And then I'll talk about the MQTT application and then give you a short demo about the application that you can use when you start using the MQTT. And then we can have some Q&A sections if you have further questions. Okay, so what is MQTT? It's like a newspaper sending system. So if you subscribe to a newspaper, and in every morning the paper boy will deliver the newspaper to you. So you have to subscribe first, and then when there is a new message, it will be delivered to you. So it's also called an publish and subscribe architecture. And it's a very lightweight protocol. So I think probably every major vendors in this industry have already supported MQTT because you don't have to pay a lot for your bandwidth or for your 4G or 3G connection because the message is so short that you don't have to pay for the traffic, and it can save bandwidth and also has very efficient communication. So the architecture is like this. First, you will have a MQTT server that is helping you to deliver the message. And so in this example, we have a healthcare on the bottom left here, and we have logistics, and we have warehouse, and we have security and manufacturers. So when there is a situation, if there is a low blood supply, and some of the industry or some of the vendors, they want to know about this. For example, the top right here, top left here, the logistics people, they would like to know when there is a low blood supply. And also the manufacturer, they may want to know this situation so they can start making more blood bags or some supplies. So when there is really something happen, the healthcare is the publisher. He will publish a message to the MQTT server, and then the MQTT server will help deliver this message to subscribers. So that is the logistic people and the manufacturer people. And what about other people that is connected to the same server, for example, on the top or on the right? Those people, they don't subscribe to this message, so they won't receive those low blood supply messages. Okay. Oh, and also, if you would like to have this handout right now, you can click on the right panel to download the handouts on the right, and there's a PDF available, so you can download it right now. So, and right now, first question is, why do we need MQTT? Okay, so we have some examples here. This one is printer services. So we have a customer who is making printers for industrial use. For example, the ceramic printing, like the place that you're seeing on the screen. And what they're doing is they want to monitor the ink supply status of the machine. So when there is a shortage of the ink supply, they can send a local sales or send a pack of ink to the customer before the customer really aware of there is something wrong with their machine or there is a supply issue with their machine. So it is life cycle monitoring and predictive maintenance. And one situation they have is the machines are installed in end users' factories. So they don't have really any control of the network or the router of the end user's factory. So they want to use MQTT because they can just have a MQTT server on the internet, and then the machine can publish this message to the internet, and then the manufacturer will subscribe to all the machine's messages. So they don't need customers to open router ports or to open their firewalls for monitoring their printers. All they need is an internet connection for their machines. Then they can start collecting data of their printers. Okay, and another example here is a water farm system. So because there is so many sprinkles in the farm, for example, here in the middle here, I circle it using a yellow pen. You can see it in the picture. So those are the sprinkles they want to monitor. So if there is a situation with this, or if there is any like a flow issue or something happen, they can receive the message right away. But because there are too many of them, so it's hard for them to connect one by one to monitor all the device using one device, using like one controller. So they use MQTT to publish the message once there is something happen in the sprinkle. For example, use the red here. So there is something wrong with this sprinkler, then he can publish a message to the MQTT server. And other sprinklers that have no problem, they don't publish anything. So the subscriber can subscribe to the event message for this sprinkler without using too much bandwidth. So it's a simple and scalable architecture for MQTT, and I will explain it later in this webinar. Okay, and another example is a small building construction IoT case in China. And what they are doing is they use MQTT to monitor their water source, electricity, entrance notification, and repair calling. And the reason they are using this is because there are too many people want to know the same message. For example, the entrance notification, the bodyguard or the guard of the community want to know if there is someone trying to enter the building, but maybe one of the residents who is waiting for his guest to visit their house, and they want to also know if there is an entrance or if there is any guest for this community. So they want to subscribe to the same message. Or if there is a fire issue within the building, then there might be different companies doing maintenance for this building, they want to know the same message. So that's when they want to use MQTT to get everyone in the MQTT system, and once there is any message, they can subscribe to it and then receive the message. And another problem they have is if they don't use MQTT, if they have so many phases for the building construction, for example, if they have one building ready and then they want to build a second, they want to build a third building, then they have a problem to connect all of them together. So considering this problem, so they choose to use MQTT as their messaging system. Okay. And what about when did MQTT start? So I'll talk about the history for it. So many years ago, because IBM invented MQTT, so what they are trying to solve is there is a very long oil pipe from maybe Mexico to Canada, and they want to monitor every pipe system or every single node on the pipe, oil pipe. And because there are too many devices, there are 4,000 devices in this system. And what they are doing at the beginning is they are using satellite to collect every message from the SCADA system. Okay, so the SCADA system will connect to 4,000 devices at once, and then polling, asking every one of them for their data, for their information, or if any event message. Then there is a problem here because there are 4,000 devices. So the SCADA system will, for example, polling those data every 1 millisecond, and then it will saturate their satellite connection on the sky. And then their CPU will be saturated also for 100% because they have to polling all the data every time. So that's where their problem is. And another problem they have is there are many department in the system, for example, the billing and the maintenance. They want to know if there is something wrong with the oil pipes, or for example, there are like 10 or 20 different companies doing maintenance for this oil pipe. They all want to know the information, but what they can do at the beginning is talk to the SCADA and get all the information. So it's also called a SCADA prison for the MQTT, before MQTT, sorry, it's before. So what they have is they have a MQTT broker here, and every device will publish message to the broker, and everyone that is interested in any topic, they can just subscribe to this topic to receive the message. So they don't have to talk to the SCADA system. They can just talk to the MQTT broker to get all the data they want. Okay, sorry. All right, so here is one of the concepts that if you are monitoring a lot of devices. So for example here, for the traditional devices, you might be aware that there is some protocol called Modbus. So if there is a thermostat and your control room wants to know the temperature, and one of your engineers, and she wants to know about this thermostat status, then two of them will asking the thermostat every now and then, like for example, one request every second. Then the problem here is that if you have so many thermostats, for example, a lot of thermostats, and you are polling 10 times per second. So if you have 6 thermostats, then it will be 60 requests per second. And if you have 100 thermostats, then you will have 1,000 requests per second. So this is the problem of client-server architecture. So the control room has to connect to every device and then polling and asking about their information every second. But you can imagine if you have another engineer want to know the message or the information, then is m multiplied by 1,000. If you have one more engineer, then you have another 1,000 requests per second. If you have another one more engineer want to know the message, then you will have another 1,000 requests per second. That will quickly saturate your network and make your network slow and unresponsive. So that's where the MQTT will be used. So, for example, the thermostat will publish the message if there is something happen in the thermostat. So, okay, it's going too fast a little bit. So the control room will subscribe to the topic first, and then when there is something happen to the thermostat, it will publish the message to the MQTT server, and then the subscribers can know that there is something change in this thermostat and know about this. Okay, and one interesting thing about MQTT is that every data or every payload in MQTT is identified by an MQTT topic. So assume that you have many temperature readings in your house. Then, for example, on the table here, in your ground floor, there is a temperature of living room, and there is a temperature for your kitchen, and there is also temperature for your bedroom on the second floor. Okay, and one cool thing about MQTT is that you can subscribe to message by a filter or by a wildcard filter sign. So if you use a plus sign here, you can subscribe to different topics at the same time. So, for example, here I have a plus after the ground floor. Then I'm going to subscribe to all the message in the ground floor. And there's also another thing called hashtag here. So this one will subscribe to every thing after the slash. So if you subscribe to home/hashtag, then you will subscribe to all the topics listed below in the table on the screen. Okay. So you already know how do you identify an MQTT message and how do you integrate it. So for example, you can use a CMTG01 as your edge gateway. So our HMI can play as an IIoT edge gateway to publish your machines or sensor network monitoring to your MQTT broker on the cloud. And for the cloud services, for example, Amazon or Microsoft Azure or IBM or GE Predix, they all support MQTT right now. So if you want to use MQTT, you can, and you don't want to build your own MQTT server or you don't want to maintain your own server, you can just rent one from those cloud service providers. And then those cloud service providers, they also have some machine learning or some data collecting mechanism or have cloud storage, just like Dropbox. So then when you publish to their cloud service, they can store those data in the cloud, and then you can process them to get a wisdom to predict any future event for your machine. Okay, so our HMI can publish to the MQTT broker on the internet, or we can also subscribe to those messages on the internet. So if you want, you can publish a command from your, for example, your control room. Then when the HMI receive the message, it can like getting a command from your control room, and for example, to start your machine or to do some maintenance work or collect some data from your machine. Okay. Another example here is that if you really don't care about cloud service, our HMIs can play or can act as a mini data center. So for example, here you can use a CMT SDR to be a MQTT broker. So all the CMT G01 can publish the data to the CMT SDR, and CMT SDR can act or be a MQTT broker. So your control room or engineer or your maintenance people can subscribe to the message on the MQTT server on CMT SDR. And at the same time, because CMT SDR can subscribe to MQTT messages, so you can also record those data to any MySQL server that is on your LAN network or on your customer's network. Okay, and also another example you can use for our HMI, that you can use MTV as a mini Kanban system. So the CMT G01 or OR HMI that supports MQTT can publish the message to the MTV, and then the MTV can display those information on a local TV or on any industrial monitors. So you can get an overview for your factories without really having a standalone PC to collecting all the data. You can just use a MTV to collect and show the information about the machines. Okay. And I'm going to show you a quick demo here. What we have here is that we have several MQTT publisher in the center here. So all those publishers, they are weather stations. They will publish humidity, temperature of the offices that we have in China and in Korea. And they will publish the local weather information to a internet MQTT server. Then we can run an application on this PC or on any PC you have, and you can subscribe to all those weather information or weather stations on your PC without actually connecting to every publishers here. And interesting is that because last year there is a very severe air quality problem in China, so that's when we decide to set up a mini weather station to monitor the weather by ourselves, to get a quick overview about the air quality or to know the status of our branches or offices in China. And let me show you here. Okay. All right. So this is the application that we have, and this is made by JavaScript. So it's a very popular language recently, and you can just build this application very easily. It's very easy to make something like this. And what I have here is we have factories areas on the left. For example, I have a factory that is you can see on the top right, like a environment and air condition system, packaging, or data station. When I select all of them, then I can get all the information that I have on them. For example, AC system, in this afternoon, the temperature, the pressure, and the light intensity of it. And also I can use a trend display to display those um, data locally. It's pulling the data out, so it might take a little bit time to get them. Okay, here we are. So you can use a JavaScript to draw the trend about your temperature, your humidity, and also if there is something happen like what we have here, okay, it's gonna pop up. Oh, you here we are. Like the packaging system is too dry or something is too hot, then we can record those messages here. Use just like event logs in our HMI, and all those data sampling and event logs are recorded on a local MySQL server using JavaScript. And on the top right, the like a push notification thing is a MQTT message. So what we're doing in this application is that we will subscribe to the humidity, the temperature and pressure from this machine, from this machine, from this machine, and then record them to our local MySQL server and then display them on this application. And also we can show a map to display all those MQTT data station. For example here, this one is the data station, and this one is the station is Korea, and this one is the air conditioning system. So you can see the temperature is changing on the icon, and if there is something wrong with it, it will become yellow icon just like this one AC system. And what you can do is you can say, I have already solved this problem or this alarm. They mark it as solved. Then it will return to blue, meaning that it is online. And if there is something wrong again, it will become yellow just like this. So you can use a map overview to get rough understanding about your machines, like in different countries or in different cities. Okay, so this is the demonstration for using JavaScript to build a MQTT client to collect information, to display information using different methods. So we have a real-time MQTT information here. We have seen that MQTT event message, and we can do map integration. We can record MQTT data purely only using JavaScript. Okay, all right, just like in this slide, we can use map integration to get an overview about your stations. And then I'm going to show you a very simple application that is called Node-RED. So if you don't really know about JavaScript, or you don't want to spend so much resource to build an application, then you can just use a simple application that is invented by IBM, and it is open source. So you can download this Node-RED from the internet without any charges, and you can run it on your CMT IPC or on your PC or on any computer. Okay, so if you start the Node-RED, this one is their editor for their node control. So what I'm going to do is I'm going to pull in a MQTT node, and this one will try to subscribe to a server that is mqtt.ihmi.net on the internet. And what I'm going to do is subscribe to a node, not Taipei, so Solar environment. Okay, and so what I'm doing is subscribe to an MQTT topic called station in Solar about the environment on the mqtt.ihmi.net, and then I'm going to use a debug output to see what I have received. So let me click deploy here. Okay, it is successfully deployed. Then I can click on the debug panel on the right. Then I can start seeing that I'm getting a new MQTT message coming in. And this is our MQTT structure or message directly from our HMI. So it looks like this is a string, and it is also called JSON. So you can see there is a humidity information that is 36%, and there's a temperature like 13 degrees right now, or pressure or light intensity. So you can quickly using Node-RED to get the MQTT message. And then what about showing this as a application that I have? So in Node-RED, they have something called dashboard on the left here, dashboard. So what I'm going to do, I'm going to put this message as a gauge on a HTML page. And how do we wire this message to the gauge below? So I will use a JSON. So convert the message to a JSON, and then let me just write a short JavaScript function here. Okay. What I'm going to do is okay. So what they have is every message in Node-RED is called MSG, and then I'm going to put the humidity from our message to the gauge. So I'm going to get the humidity from the original message and then put it in as the major payload for the gauge. Okay, 0 here. Okay, and then wire them together. Okay, and this dashboard, then we have to configure it to say how do we display on the web page. So for Node-RED dashboard, you have to create a UI group first and create a UI tab. So let me add, and it's a very simple step. So you just click add and done, then use and click deploy. Okay, so let's go back to the Node-RED UI interface. All right, so you can see there's a gauge displaying the humidity directly using a gauge on the screen. But you can notice that it's scaled from 0 to 10. So then we can go back to the administrator interface. Wait a little bit here. All right. is, okay, I put it somewhere else here. Yeah, I happen to mess up with the example that I already have. Okay, this one is what we have just created. So the gauge here, you can set a maximum message, for example, 100% here. Then you can also adjust the size of it. For example, 6 by 7 on the screen. Click done and click deploy. Okay, then let's go back to the user interface here. You can see now it scales from 0 to 100. And also you can configure this to hide this text showing on top of the gauge. So we can go back to the administrator interface. Okay, and scroll down so we can say the gauge. There is like the unit or the value we want to change about it. And so this is a simple way that you can just like subscribe to an MQTT message, convert it to JSON, filter the message, and display it quickly on a HTML or a web page without using any further tool or any compiler or any additional human resource to develop the system. Okay. And also, what I have already built on top is you have already noticed that there is also a notification on the screen in the UI interface. So what I'm doing is I connect to a MQTT server and subscribe to all the events for all the stations and for every event that is happening on every station. Then I will put it as a JSON and then split the message. And what I'm doing in the split message is that because the station name or is the name of every MQTT publisher is embedded in the message topic. So I will split the topic string using a slash and then get a second element of the topic. And then put the message of the event. So let me just show you quickly here that let me display this debug node and display this here. Okay, clear, and then wait a little bit. You will see that the event will coming in through this node and yeah, right here. So you can see that if there is a event message from our HMI, you can see that there is a message showing the actual human readable content, and there is a status or the trigger time of it. So what I just did is parse or split this message. Like the topic here, you can see it's a little bit small here, but it's called a AC system, and there is a dot event for the AC system. So in the split message here, I use a slash and to get the AC system. And then for the payload, I just get the message right here at just like this one on the screen. Okay, so let me click deploy and back to the UI interface. So you can see on the top right, it's showing very quickly. So it's a notification from the node that I just showed you. So right now I can have a very simple monitoring system using Node-RED without using actually writing a lot of codes or writing a lot of different letter or something to monitor this MQTT system that I have. Okay, so this is a short demo about the Node-RED. So you can build a simple and very quick monitor system using our HMI and MQTT server using Node-RED. Okay, and here comes the problem. So when will you use MQTT? So if you want to telemetry to monitor your machines, then it's very suitable. And if you want to get notification, just like a subscriber, so this MQTT will be very suitable for this application. But because MQTT is a decoupled system, so if you want to send a command, it can be done, but kind of tricky because you want to have a new topic for the command, and the HMI has to subscribe to this command and then publish the command result to another topic. So subscribe here and publish on another topic. And inquiry is the same thing. So if you want to use MQTT to collect messages, it's very easy and very suitable. But for commands, it can also be done, but is a little bit tricky. Not very intuitive, just like Modbus. Okay. So some of the customers, if they already know about OPC UA and MQTT, and the first question they are going to ask is when they are going to use one of them. So if you only monitoring using one client, one server, or only 2 clients and 2 servers, then you can just use OPC UA to get all the information, because it's very suitable for one-to-one communication used as an integrated architecture. But if you have multiple publishers, I'm sorry. Okay. And if you have multiple publishers and you have a lot of subscribers, then it's very suitable that you use MQTT, because you can use flexible topics to get control of the messages. And if you have a very limited bandwidth, or you don't have control over the publisher, then you can use MQTT, because this is an outgoing connection to MQTT server. And most firewalls in customers or in end users factories will not block outgoing connection. So your machines, if you want to collect data from your machines, then you can just tell your customer to give your machine an internet connection, and you don't need any firewall exception or open any ports for the customer's firewall, because it is an outgoing connection. Then when the customer connect your machine to the internet connection, then you can start monitoring your machines. Or you can have a 3G dongle or 4G dongle using CMT SVR, and then you don't need any internet connection from the customer. You can directly using dongles to connect to a cellular network to start collecting data from your machines. Okay. So our HMI plays as an IoT edge gateway for you to integrate your message or integrate your machines into customers' SCADA system, MES system, or ERP system, or any IoT system. So what I just said about CMT 01, that it supports so many protocols, and it also supports MQTT, supports OPC UA and Modbus. So if you want, you can get our device like this one. It's a very compact and a very small device, and can be integrated into any PLCs that you have. Then you can start collecting the machine's data using MQTT. So using our CMT G01, you can use the MQTT features of it and using the 2 Ethernet port or using the 3 serial ports to connect to your PLC devices and start monitoring your device right away. Okay, so this is the, what I've just shown you is that the MQTT, what is MQTT and how our HMI fits in the MQTT system and the applications for MQTT, and a short demo about our application using JavaScript, the MQTT data station, and the Node-RED demo if you want to build a quick and very simple application for MQTT system. And then if you have any questions, you can ask right now or you can raise your hand, then I will answer them right now. And if you have further questions, you can also ask our application engineer to know more details about the MQTT that I just talked about in this webinar. All right, thank you.